Hi, everybody. My name is Jonah. I'm from Sauce Labs. I've been really happy to see a lot of people here talking about, like, we had people talking about customer service, and we had people talking about continuous deployment and testing. I think Google mentioned that. So my name is Jonah. I work on a team of developers that works on the sort of open source ecosystem around the applications we have at Sauce Labs. But I'm here to talk about like testing. Like testing, I can't stress enough how important this is. I guess people here, how many of you are proud of your test coverage and your test suite? It's like, I see a few hands. Wow, that's awesome. But how many people wish they were proud of their test coverage and test suites? Yeah, it's everybody. It's always everybody. Everybody wants it. But no one ever has it. But when you do, you're really happy that you do. So, I mean, what is DevOps about? I mean, it looks like, but it's really, if you read about some of the original papers talking about the idea of DevOps, it's not just about dev, and it's not just about ops. It's DevOps and QA. Because, I mean, if you have this system where we're trying to slowly make our entire like agile loop faster and faster so that we can release our product faster and adjust to changes in the market faster. And if suddenly now your dev team is on like Scrum and Agile and all those things, and they're able to quickly process things, and now your ops team is including DevOps sort of things, and rather than having a single machine that you have to keep running all the time, now you can provision like 100 machines whenever you want them, and now that's all automated, and your whole systems can come up at any moment. But what about QA? If you're doing QA with a manual team of people who have to spend all day, sometimes more than a single day, testing every part of your website or your app manually, like a room full of people tapping on something, or someone who has to type in the same name of a user like 100 times in a day, and they have to click through the site, and they're sick of the site, by the way, at that time. And then as soon as they come back to you, and they're like, okay, good, we checked it, like it's good to go, and you're like, oh, I just pushed new commit. There was something, so I just changed the configuration. Now they have to do it all over again. And so if that's, and how can you deal with like being able to provision machines in like 20 seconds, but it takes like a day or two for QA of the entire thing? So you can't afford to wait on a manual QA team, right? And the developers, they need the fast feedback loop, and the managers, they need an agile organization. Now, this doesn't mean get rid of the people who do manual QA. Like, their job is very important, and when they're passionate about their job, it's great. But you can't have their job just be robots where they are like following a Mechanical Turk sort of scenario where they're clicking the same things all day long. Like they won't be happy with their jobs. But if you're able to automate your tests, now they can find new ways to break your app. And when they find a new way to break it, now you can create tests for the new way that they broke it. And you just add that test to your whole test suite, and boom, like they can continue finding new ways to break it. And you can make sure that that problem never happens again. And what else do you get from testing? It's not just about, when you add automated testing, you're not just getting the faster time for how long you can verify there aren't any bugs in production and how quickly you can get something deployed. But you also end up with better code architecture. Because sometimes if you're writing code, if one person writes a bunch of code, and good, it works, and give it to somebody else, and somebody else has to make sure that it does work every day. The developer never gets feedback on what it's like to test the own software that they made. But when you have developers writing automated test scripts for their own code, you quickly find ways to make your code more modular so that it's easier to test. If you're working on a project where you need to test okay, I need to test this certain models in the database, but now all of a sudden there's dependencies. It's like, oh, well, this relies on the fact that there is a database, and this relies on the fact that there is a user model in the database, but you can't have a user model without a credit card model, so now there's one of those in that database. And suddenly, if you have to require all these dependencies in order to test something simple, then it takes so long to write the test, and it's so confusing that you'll just give up, and you're like, oh, okay, well, we'll test it some other time, it'll be good. So this is why, but if you're writing it, and you notice that like this function you wrote is difficult to test, then you're going to restructure and re-architect your code. When you have more modular code, it's much easier to test it. And so with testing in mind, then you now will organize your code better. Another thing you get from testing is you have a definitive list of what your program, your app is supposed to do. I don't know how many times I've worked at a company where somebody creates some sort of like, you're a newer developer on the company. They tell you, fix this bug or make this new page or something, and you like do whatever. And then they come back to you after QA and they're like, oh, well, you broke this page. You're like, I didn't even know that page existed. Like, and you find that there's 5 other products you didn't know existed, and there's someone whose job it is, and every day they use it. And they're the only person who uses it, no one even knows they exist, but they need that to work. And so when you have tests, if you're replacing some module, and you have all the tests for that module, which the tests are accrued through years of development of other developers. So every time something is broken, they add a test for that thing that's broken. And now, if you need to replace, let's say, do a complete rewrite in a different language or a new framework or something like that, but if you have their tests and you read their tests before you start, and their tests are organized, you can see the problems that you're going to encounter. And you can then design something where you solve all those previous problems in your initial design. And you don't have to encounter the same bugs that the previous developers encountered, and they don't even work here anymore. So now, if you're running these tests, right, you've got, let's say, you're working on this great test suite, you've got everything up and running, this is great. The problem with having a great test suite is once writing tests is easy, you keep writing tests. More and more and more and more tests, which is great. But as you have all of these tests, now all of a sudden you need an entire infrastructure team in order to service the infrastructure that your tests are running on. Right? You need like a staging server, but if you have a distributed system, you actually need like an entire staging cluster, right? And now if you have another database, let's say you add a new data center to your system, to your production system, now maybe you want 2 databases simulated in your staging so that you can make sure that like your failover of one to the other works or something like this. And all of a sudden it turns into like a full-time job keeping all this stuff running. So you don't have to run all these things. You can use these people, the people at Sauce Labs. Sauce Labs runs test infrastructure as a service specifically for test automation of browsers and mobile apps. So now we're only talking here, I'm only talking about functional testing of automation of browsers and apps. And the automation of browsers is traditionally done through Selenium. Selenium, like a project that's a few years old. How many are familiar with Selenium? Okay, great, all right, great. Selenium, it has its problems, but it's what everyone uses. It's open source, so that's good. So Sauce Labs hosts an entire cloud of VMs with every version of every operating system, and on each of those is installed every version of every browser. And we're talking every browser. And so every time a new version of the new browser comes out, Sauce Labs adds it immediately. It's available. We even have like the beta versions of Chrome and like Firefox Aurora, stuff like that. And that way, like, if you're doing this in-house, then you're the ones who have to keep all this stuff going. You would have to have a whole team of developers. Every time a new browser comes out, they have to add it to your system. They have to make sure you have 100% uptime. They have to make sure that your capacity scales with your test usage, blah, blah, blah. So Sauce Labs does all that for you, where you just point your Selenium tests at our API, and boom, now you're running your tests against everything there. So, I have a short demo here. My internet is kind of spotty, but we'll see how it works. So I wrote here, this is using JavaScript, but you can use any language to write Selenium tests. This test is supposed to log into my Twitter account and tweet something we say. But instead of running it locally with Selenium, I added a few parameters to our desired capabilities here, where I told it normally I would point my Selenium tests to localhost/wd/hub. But instead, I'm pointing them to ondemand.saucelabs.com, port 80. I'm also adding my username and my password because I'm paying for the service. So let's see. Right. So hopefully this will work here. So I'm just going to run this, and we'll add a message, something like, hello from DevconTLV. Oh, I should add a hashtag. Let's see if this works. I don't really know if it's going to work because I didn't want to test my own Twitter account so much with all the test messages, but see it's here. So okay, so what's happening now? It's running the test, and here we have my Sauce Labs dashboard, and should appear here as a currently running test. The latency is low. Okay, it's loading my current tests. Right now our data center is located, oh, here we go. So there, look, right here we have something running. And this is running on Chrome version 41. And its VM's currently running. And if we clicked on it, it shows a video of what it was doing. I'm not even going to bother to click that now, because by the time the video loads, it'll already have completed. So let's just see if it has posted it to Twitter. Not yet. I could have done something wrong. It says it worked. Oh, it finished. Maybe Twitter's the one that's not updating. Ta-da, yeah! Cool. So this is something that can run on every single commit, to Jenkins from sliding straight into my CI and my continuous integration, continuous deployment. So I could easily, that was just running one test that logged into Twitter and did that. But instead of doing that, earlier today I wrote, I had a test Twitter account that I was using, and I wrote like I just took that command and I was running it, in the background, and so I was able to just like pop in like 5 different commands all at the same time, just post A, and then I chose different browsers, and it ran all like, I can run 10 to 100 to 1,000 tests concurrently. So the good news here is that we saw it took what, it took maybe something like, how long did it take to run that test there? It was about 30 seconds we were up here, right? But if suddenly I want to test that same Twitter message, but on 10 different browsers, that wouldn't go to 10 times 30 seconds it took. It would still be about 30 seconds. If I went to, let's say, 10 different browsers posting from 10 different Twitter accounts, it would still take just about 30 seconds for all those to go through. So, what is this? So what about mobile, right? So, websites are fine. We can test our websites. We can test them in parallel. We can do anything we want that we could do with Selenium. What about mobile? And so there's an open source project called Appium. And Appium is an open source project. Some of the developers at Sauce Labs work on it, myself included, but we're not the only developers that do work on it. You can find it on GitHub already. And Appium is exactly like Selenium, but for mobile. So I can use Appium instead of a Selenium server, and I can control iOS simulators, Android simulators, and also real Android phones and iOS phones connected to my machine. It works exactly the same. You can use the same exact clients that you use for Selenium in order to write your tests, and you can use those for Appium. Because Selenium uses a protocol called the JSON Wire protocol to send commands from the browser to the test server. And Appium uses a superset of that same protocol called the Mobile JSON Wire protocol. And it's the same thing, except that what it adds are a few things that are available on mobile that aren't available on browsers. You can change the orientation, you can do touch gestures, you can put GPS coordinates, you can do all sorts of, you can background your app, things like that. Appium can test native apps, Appium can test hybrid apps, Appium can test the native browsers. So you can choose to use your same website test. So if you want to test the mobile version of your site, you can use Appium. If you want to test your native app, you can use Appium. If you want to test, so Appium has a few fundamental sort of things to how it does what it does. It's not the only version for mobile testing, but it is open source, and it uses the underlying automation frameworks provided by Google and Apple. So if you, it can use the same exact code, the same exact app that you push to the App Store. It doesn't try to decompile your app and add instrumentation or anything like that. Here's an example of, I wrote a small script that this is like a drawing program, like Paint, and I wrote the touch gestures that simulate like someone's fingers on the screen, drawing the Appium logo. So this is just demonstrating that you can create arbitrary touch gestures on your screen, even multi-touch. This is like 3 fingers going down a circle, 3 fingers coming around, making that. And so you can really use Appium in order to like test all of your app everywhere it is. So, oh, I have a quick demo of Appium. What? Whoa. So here I'm just going to do it locally, and I'm just running the Appium server. It's written all in Node, so bum, 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 there it just went up. So now this window here is waiting for commands over the local host like HTTP connection on port 4723. Down here I'm just going to run just a really basic test. We have a really simple sample app that's just like almost like a calculator, and this is the test that we use for testing Appium and stuff. So as the test is starting, you see Appium is logging all this information, and as it's logging the commands, the iOS simulator is popping up here. So it started the simulator automatically, and now it's going to go through and continually sort of put different values into these text fields and then make sure that it's computing things correctly. So first it's like making sure they exist. It computed empty and it got 0, and now it's typing in things like 5, like 1, hits the button, gives us 6, that's good. So what it's doing is it finds the elements, it's then inserting, it's typing into the fields, it's clicking the button, and then it's getting the value of this text field there. And you can also see like the keyboard's down here and it's kind of like typing on it as it goes. So that's that. So, of course, you can use Appium on Sauce Labs as well. Appium's open source, you can use it yourself, you can run it locally like I just showed you. I could plug like phones into it. The problem is eventually I don't really want to have like 20 Android phones on my desk, you know, and I don't want it taking all my CPU time. I don't want all those simulators popping up. Android simulators tend to like crash your computer pretty quickly. Sauce Labs, the same way you specify what browser you want, you can specify any version of iOS, any version of Android, and it'll be able to emulate the same and run on simulators and run all your tests in parallel there too. So it's all the same. So now that we have this automated cross-platform, language-independent way of like doing this testing, now like you have to bring that into the flow of your DevOps process. Because now that you can run these tests super quickly, you can sort of hook up the whole thing, and your loop for how quickly you can go from a new feature to it being launched, or from a bug to it being fixed and launched, is right there. And earlier, I think one of the speakers was talking about one of the speakers was talking about how their QA team is able to basically get bugs from the customers, and then they come up with like a video of a reproduction of the bug, and they give that to the developer. But just imagine if you had QA more tightly tied into your whole DevOps system and DevOps flow. If instead of a video of your reproduction of a bug, the QA person can write, or with the help of a developer, can write an automated test that reproduces the bug. So now when the developer gets the bug report, it's not just getting a bug report with the customer, but they're also getting an exact test that replicates it. And if you had that test integrated into your issue tracker, you could have that test automatically connected to your build and have the test inserted there. And the developer knows as soon as they've fixed the bug when that test passes. And also, if that test ever fails in your build, let's say a month later, it can bring back that original issue and reopen it and assign it to the developer. And this is just one example of what you gain when you start tightly integrating your automated testing with your entire DevOps flow. So speeding up the development cycle, you make it more agile, and that's everything we're looking at. It's just faster and faster and faster time from when something happens to when you can react to it. And yeah, so it's all about like coming up with new tools that help us to move faster than we're used to thinking. Thank you. Are there any questions? Question here? So you're asking, what about Sauce Labs' staging environment? Great, yeah. So he's asking questions about how do you expose your staging environment to Sauce Labs, right? Because our cloud runs browsers, but they have to access the staging version of your site. We have another tool, it's called Sauce Tunnel or Sauce Connect. And what it does is it runs behind your firewall and creates a secure tunnel from your staging servers through your firewall to a secure VM on our system. That VM was created just for your tunnel, and then that VM now sends the commands to the browser and back. It's encrypted the whole way, and that's how the pass-through goes. On the issue of security, part of the reason why what Sauce Labs is difficult is because in order to guarantee security, we really, really want to show our customers that they can rely on everything being safe. So we never have any of your source code, right? All we get are these commands, the Selenium commands of how to control the browser, and we know what your staging website looks like, right? Additionally, when you run one of your tests, we spin up a fresh VM just for your test. It opens a fresh install of a browser, and it runs your tests. And as soon as your tests are finished running and you close the connection, which, you know, my test took like 10 seconds and your test might take like maybe 10 minutes. Some people run like 2-hour test suites, but I really don't suggest it. Breaking it up into smaller like 10-minute, 5-minute tests is really better for you getting your reporting and better for your test runner and also better for our systems as well. So if you're only running, you run like a 10-minute test. As soon as your test finishes, we completely kill that VM. It's gone forever. Next time a customer wants one, we spin up another. So that's one way we have of guaranteeing security where no other customer ever has access to a VM so that they can never, add any code that would watch what you're doing. And then also we have the encrypted tunnel from behind your firewall to behind our firewall. Any questions? Question over here? Yeah, so he's asking about how quickly we can boot our VMs and how that's optimized. So one thing we do is we don't run an AWS, we run our own cloud. And what we're able to do is, we keep a pool of fresh VMs, right? So we have a pool of VMs that are booted and ready to be used by a customer, but have never been touched by any machine yet. And then, but still, the pool has a lot of churn, right? And we don't want our pool to be 10 times the size of our usage because then, we're spending money in all those VMs that aren't being used. So, yeah, we've definitely optimized all of our images to boot extremely quickly. One advantage we have is we know what these machines are going to be used for, and that's for running a browser. And so we know, and we also know under what environment they're going to be running that browser. So right now, we're able to start, I think we can start a Linux VM in just under 19 seconds. We can start a Windows VM in a little bit lower than that, I think around 17, 15 seconds. We can start an Android emulator in something I think between 9 to 12 seconds. So yeah, there's definitely some sweet stuff. I think those numbers actually beat some recent numbers I saw from Google, but then again, we've optimized it for the situation. Oh, that's right. Yeah, we're sponsoring the drink up afterwards. It's at 11 and 7. Oh, thanks. Cool. 9 o'clock, yeah. Anybody else? Cool. Well, thanks for having me. Yeah.